All attendees are in listen-only mode.
All right, hello everyone, and welcome to the Directions Mag Geospatial Webinar Program, sponsored today by our friends at Hexagon. I'm Rebecca Flowers with Directions Magazine, joined by our webinar producer, Lynette Quaglia. If you have questions about your connection, just drop us a note in the chat and we'll do our best to help you. We encourage you to read our new feature articles and daily news, as well as view more geospatial webinars, always free for geospatial professionals at directionsmag.com. We're standing by to take your questions. Type those questions into the question box at any time during the webinar. We'll answer as many questions as possible during our Q&A time today. We're also recording today's webinar, so keep an eye on your inbox in the coming days for that email with links. We appreciate your opinions in our poll and the post-webinar survey. Now let's get to the main event. Welcome Tek Cheng from Hexagon. We're looking forward to learning more about M.App X.
Okay, thank you, Rebecca, for the introduction. Good morning, good afternoon, and good evening, everyone. Thank you for taking time to attend this webinar. My name is Tek Cheng. I am based in Singapore, a little red dot at the southern tip of Peninsular Malaysia. A bit more about myself. I came from a military background, and I have witnessed some of the technology advancement for imagery exploitation. I started off using this massive light table, doing imagery exploitation on aerial photography and films, subsequently moving on to the electronic light table. Now with Hexagon Geospatial, I am glad to witness another breakthrough with our M.App X solution, which we are going to learn more about it in today's webinar. Before I carry on with my presentation and to ensure that you are awake, let's do a poll to let me understand you better. Can you tell me which industry you work in? All right, I can see that a portion of the audience also come from the defense industry, where historically imagery exploitation is predominantly deployed. So one of the best examples is how a nuclear missile crisis was averted in 1962 using imagery analysis. Once just a tool for defense, imagery exploitation is no longer a military specialty. Fueled by the explosion of commercially available images and open data, imagery exploitation is now widely practiced across a broad spectrum of users. As I can see from the poll, the diverse industry the rest of the audience are from. Nowadays, imagery exploitation can be seen in a wide variety of industries and applications. Agricultural producers rely on imagery to monitor crops. Forestry agency uses it to monitor trees and deter illegal activities. Oil and gas and mining industry uses it to monitor their operation. We also see civilian agency using imagery exploitation for disaster management from storms, earthquakes, forest fires, and other disasters. So all this in different industry uses imagery exploitation to enhance their understanding and interpretation of the scene, allowing them to see distant objects without setting foot on the ground, enhancing their surveillance capabilities as the operation is ongoing. Eventually sharing this information throughout the organization so that everyone have the latest information for planning, reporting, and decision making. While the skill set and workflow for imagery exploitation are no longer residing within the military, the pain point of traditional imagery exploitation still exists across the industry. So let's try to understand some of these pain points. So traditional imagery exploitation is a very computer resource intensive operation. It usually requires a very powerful workstation, like the one shown here, for all the different image processing and analysis workflow. A big organization can easily have hundreds of such workstations. So these workstations are expensive to manage and maintain. They are difficult to upgrade, and the processing capability is not readily scalable. When applied to a remote operation like deploying on-site or in the current COVID-19 climate where everyone is working from home, this huge workstation poses another logistical challenges. When it comes to imagery exploitation software, these desktop remote sensing software are very powerful, able to run a variety of different processes and analysis, which require the hands of a skilled operator. They are usually armed with a broad set of capability, but to be proficient in these different processes requires extensive training. And for non-true breed geospatial analysts, it's a time-consuming process to learn everything, and they face a steep learning curve. Even for me, till now, I'm still learning something new every day. So understanding some of these pain points faced by traditional imagery exploitation process, M.App X is crafted to help alleviate some of these pain points. So what is M.App X? Using our extensive knowledge on ADAS Imagine, a world-leading remote sensing software, we created M.App X. So M.App X is an imagery exploitation solution that can run on modern browser. So you can use M.App X on any platform, ranging from desktop, laptop, to any portable devices like tablet, even handphone. So the solution can be deployed both on-premise or on the cloud. It allows users to connect and access imagery on different databases from different sensors, examine the data with its powerful array of tools, running processes like image adjustment, image geoprocessing, and analytical workflow like measurement and annotation. You can create illustrative and interpretable maps report that can be saved in one place and be easily shared, giving everyone in the organization the most current information. Allowing decision makers to have instant access to this latest information to make real-time, data-driven, actionable decisions. So being an imagery analyst myself and have transited through the traditional imagery exploitation processes, I can fully appreciate what M.App X can bring. I'm going to share the top 6 functionality on my list in M.App X. So the number 6 on my list is the interface and smart bar. So M.App X comes with this clean and compact user interface, where the smart bar and icon are neatly located at the top and side. Additional information are clearly shown in the title bar and the status bar. So decluttering the whole user interface, giving me a very clean look that maximizes my working area for exploitation work. So the command bar, which is located at the top of the application, contains all the different tools that are required for an imagery exploitation workflow. So the tools are organized in related groups, making it easy to find and navigate. The groups can be further expanded with all these drop-down menu containing additional functionality. The smart bar will also auto-resize if you are working on a smaller screen, consistently keeping the interface clean and compact. So the number 5 functionality on my list is the ability to view the images in different modes. So I can change the view depending on the type of analysis I am doing. So if I need to make a precise image measurement using the sensor model information, I can use image space, which presents the original pixel with the greatest accuracy. This mode eliminates any distortion or visual artifact. So M.App X, like ADAS Imagine, support numerous sensors and their sensor model. So the number of supported sensors increases with every new release, making it ready for some of the latest sensors in the market. So I can easily switch between the different modes with just a click of the mode button. If I'm working with a multiple image, I will use the map space mode. So the map space mode applies auto correction on the fly to display the images aligned to an Earth coordinate system. So I can display multiple images with different coordinate system in this mode. So if Earth coordinate system, EPSG code, DEM, ellipsoid, project transformation sounds alien to you, no worries. You don't really need any in-depth knowledge about all this jargon and how the project transformation works. What you really need to understand is the coordinate system that your organization work with, be it lat long, UTM, or MGRS. So all these different projection and their projection transformation are taken care of by M.App X back engine, professionally and accurately. So with a click on the display mode button, I can switch from the map space mode to a 3D mode. So people are seeing the value of a 3D environment with trends of company acquiring 3D visualization technologies recently. So in Hexagon, we have foreseen this potential and what image analysts can gain from a 3D view. So we have integrated a 3D environment into M.App X since the last version. So sometimes when you are viewing in a 2D mode, it could be difficult for us to perceive terrains and contours. So by draping the imagery over the globe using a terrain model, I can easily recognize things in a familiar context because that is what you see in the real world. So visually, I can see things differently, be it an upslope, a downslope, is the object a convex or concave. So I can enrich my reporting with more information, like, example, I'm traveling up a gentle slope or even down a steep slope. I'm walking beside a cliff or a mountain. So all these are very visually, you can decipher with a 3D environment. So the number 4 function on my list are the tools in the command bar. So all the tools in the command bar are created for imagery exploitation. So some example like the overview window. So when you are doing imagery exploitation and when you zoom into a very small area of interest, you tend to lose reference to the other area. So the overview window provides me a spatial reference to the whole image. And when I am exploiting an image, I will constantly zoom in, zoom out, rotating the image and panning around, which usually make me lose track of where I have exploited. So a snail trail indicator can be activated to tell me which area have I visited. Alternatively, I can also use the pattern roaming feature, which provide an easy way to navigate through the image. So it moves through the image in a predefined pattern to ensure that all parts of the image is covered. So when I am working with 2 images or I want to do a change detection, I still have the standard option of viewing 2 images by splitting the browser window to view the image side by side. Or I can also open a separate browser for a multiple monitor exploitation. And of course, I am able to geo-link them all together to have a synchronized view. So when I pan and zoom on one image, the other image will follow. I can also stack the different images together and compare the image using the transition tool. So there are a few options for the transition tool. I can do the left, right, or the up, down swipe, or I can use the transparency or flicker option. All this allows me to quickly see the difference and changes between the images. And the number 3 on my list is my personal shoebox. So have you ever encountered times when you don't remember where a certain image is residing in your server, or times when you forget which was the last image you have exploited? So the shoebox helped me to manage my projects or areas I'm working on. So I can create a shoebox for each project or areas. So in each shoebox, it provides a reference to the data on the server, telling me where the images is residing or the last images I am working on or have exploited. I can also use it to store common file like a feature file or annotation file, which I always use for that specific area. And when I know I have some new data available, I can easily search or browse for that data on the server and add them to my Shoebox. Knowing that the previous data is already in my Shoebox, I can quickly jump into analyzing my images. So I don't need to waste time trying to recall where or what image I'm exploiting or have done and go back to the server and search for all these different info. And the number 2 on my list is the image display and adjustment function. So in M.App X, I can display the image in different ways depending on what information I am looking out for. So for different type of images, I have different display method that uses a variety of image processing algorithm. So for example, a terrain file, I can choose to display it as a grayscale image, as a shaded relief, or a pseudo color. And for multi-spectral images, I can also play around with the different band combination to create the color that I need to decipher the information. So the ability to present the same data in different methods can help me in my presentation and information extraction. So other than the different image display, I can also do image adjustment to the image. So why do we need to do image adjustment? So first reason is because everyone sees things differently. So some of you may like your image brighter, while others prefer it darker. So with the image adjustment panel, I can adjust the image based on my personal preference. And the second reason is there are occasions when the image is not cloud-free, especially in my region where it's constantly cloudy, or during the times of the acquisition, there may be shadows in my area of interest. So I can make the image brighter to view these hidden details under the shadows. So other than a common brightness or contrast adjustment, I can use other adjustment tool like a resample method to smoothen the pixel, or a dynamic range adjustment to stretch the pixel level. So depending on the display method, different adjustment tools are carefully selected and displayed in the user interface. So these two really help me interpret my image better and see things beyond the obvious. And the number 1 functionality on my list is the geoprocessing power. So M.App X integrate the spatial model engine from ADAS Imagine. So this model allows a non-true breed analyst to do intricate geoprocessing without the need for extensive training. So an example is this helicopter landing zone model. So what I'm trying to do is to find a suitable landing zone for a helicopter. So the cool thing about the spatial model is I don't really need to know the intricate calculation needed to find a landing zone. I only need to understand the parameter that I want and tell the model this parameter. Example, what is the minimum area size I am looking for, the land type like scrub or grassland, and how steep is the gradient because helicopter cannot land on an area where the gradient is too steep. So the model will automatically take care of the rest. Then I just need to load the result and determine the best landing zone. I can also adopt this model for other things like finding a deployment site or finding a storage area or anything that require a space calculation. Similarly, for doing a line of sight analysis, I just need to pick 2 points, one for the observer and another one for the target, and I just run the model. So once done, straight away the result will tell you if the target is visible from the observer. It can even give you a profile view of where you can and cannot see. So using the model save me times on the processing and give me more times to focus on my analysis, which is what I'm paid to do. So using the result, I can quickly do some quick annotation and churn out a map report where I can send it out or save it in the server for others to access, ultimately shortening the geo-op cycle. So this model processing capability equipped me with expert geo-processing skill with basic knowledge. So M.App X came preloaded with over 50 models, which you can use straight away. Of course, there are options to expand the collection. So if you are ADAS Imagine user, you can also develop your own model with the spatial model editor and add them to M.App X. Or you can join our online community at community.hexagongeospatial.com, where many others users post their own model. You can easily adopt and update this model to your own use case. So in summary, M.App X is a browser-based geospatial analysis solution powered by experience from a world-class software. It promotes the ease of use for new, non-traditional users while meeting existing analyst needs. It simplifies data integration with support for numerous data, and it helps organizations reduce investment in powerful hardware and maintenance required to deploy and update all these desktop products. It's able to foster internal and external collaboration through a common resource and file sharing. And finally, it empowers decision makers with up-to-date, actionable information instantly. With that, I end my presentation. Thank you. Back to you, Rebecca.
Thank you so much. That was great. I hope you have a few more minutes to answer some questions for us. We did get a few in. So the first question from our audience is, can you customize the report?
Yes, of course, we can customize the report. So M.App X shipped with 4 report templates. So you can actually edit and add your own format by just defining the map layout templates in the system.
Okay, great. Can you integrate or customize M.App X, and in what ways?
You want me to take some of that, Tek?
Yes, sir.
Okay. Yeah. I mean, M.App X is it's a client-server system. It's built out of various modules and components. It's got a back-end server for serving imagery, for running the spatial models he talked about. The front-end client is a web client, and there's a number of points of extension and configuration. A lot of them based around the spatial modeler, as Tek has said. So on the right-hand side, he showed you a panel with a lot of geoprocessing capabilities in that. There's a mechanism now, and as of this release, made much easier to do, to add your own custom entries into that panel, which will have a spatial model behind them. You can add things on the back end. Imagine the underlying toolkit. It allows you to add new kinds of raster formats. If you're a C developer, those can be added, put on the back end. You saw that the report can be customized, and there's the ability to insert other things in other places in the user interface. So perhaps that answers the question.
Thank you very much, Brad. Here's another question we've gotten in. Is there a user management module in the solution?
Oh, yes. There's a user management module in the sense that you can define who the users are. So yes, I mean, M.App X has an authorization. You log into it. To be able to log in, you have to be an authorized user. And there's a management panel or management web app that lets you define the users. It also lets you view the usage and monitor usage over time, because M.App X is a subscription product, and subscriptions are based on usage and/or time. So yeah, there's tools for monitoring those things.
Okay, great. Does it have the facility to import cloud-based data from the servers?
You want to start with that, Tek, or you want me to take it?
Brad, you can take it, no problem.
Okay, so first off, M.App X, as he mentioned, can be deployed, on servers in your enterprise, or it can be deployed on the cloud. And most of the movies that Tek showed there were made from using our instance of M.App X that's on the Amazon cloud. And so in that case, of course, the data was coming off that cloud server, but that's probably not what the real question is about. I think the question might be about, well, what if I have something like data stored in an S3 bucket? Can M.App X get to that? And the answer is sort of qualified, because it can. The underlying libraries that M.App X is built on can read data out of S3 buckets. But there's some provisions on that. Number one, S3 bucket performance is not great. S3 is not really a file system, and so to get good performance, it depends upon sort of the organization of the file format. So that's why there exists a thing called cloud optimized geotiff, COG, which is there because if you just it's a plain old TIFF file on S3 storage and try to access it through the libraries that exist, it's just not as highly performant as if the way the data are arranged within the structure were made to be accessed in larger chunks. So we can access the data that's there if a configuration file is set up to do it. What we don't have is just an interactive browser to go discover that data. You kind of have to know it's there. So it's a yes and no.
Okay, great, thank you. Here's another one. We've got a bunch of questions coming in now. How different is it from the ERDAS Imagine software?
Well, we don't have time to answer that question. Personally made the spreadsheet of several thousand entries of what Imagine can do, and then gone and checked on what M.App X does. M.App X is it's a subset of ERDAS Imagine. You know, it includes the spatial modeler, so any spatial model you run in Imagine almost can be moved to M.App X, so that covers a big chunk. But there's lots of things like hyperspectral processing in Imagine, and a lot of the elements of the photogrammetry that are in Imagine. A lot of the just interactive desktop things aren't in M.App X yet. M.App X is that set of tools that initially we felt were the most useful and asked for by image analysts, plus all the background geospatial processing that it can do.
Okay, great. Looks like we probably have time for another question. So can you overlay other features such as a fire boundary, transmission line, that sort of thing?
Do you want to take it, Tek, or you want me to grab that?
Please.
Okay, so sure, yes. I mean, M.App X so Tek was showing you really just imagery, but it's not limited to just imagery. He was showing you how, you know, when he did that the images are all reprojected on the fly to fit the coordinate system that's selected for the view, and that includes orthorectifying if they need to be orthorectified. But in addition to imagery, we can also display features. We use WFS, the WFS protocol, and those features likewise get reprojected on the fly. And as a matter of fact, one of the nice things is that if I have an image that I want to look at in image space, which means the image hasn't been orthorectified or reprojected, it's just in its raw form, but it has a sensor model, M.App X is able to take WFS features and sort of run them through the inverse transform and to convert the features to image space and overlay them on top of just an oriented image. And that's really good because oftentimes you might receive data, you don't have time to go orthocorrect it, any of that sort of thing, but you'd like to see how these features line up on it. And you can do that with M.App X. And those features can be whatever the features are, right? They can be linear, aerial, and point type features.
Okay, we did have one final question. I'm not sure if you answered this in your when we talked about it previously. So if you did, forgive me. But the question is, will it work on Google Cloud with data stored on a Google Cloud instance?
Well, my answer would be most likely. We haven't, we haven't run that configuration, but I don't see any reason why it would not. We install M.App X on enterprise servers and enterprise data. We've got M.App X installed up on AWS using AWS data storage. But to date, yes, we have not installed it on Google Cloud so that I can give you a definitive answer.
Okay. Well, everybody, we are running out of time. So thank you so much for being here to attend today's webinar. If we didn't get to your questions, we'll send you emails with responses after the webinar. Remember that today's webinar is being recorded, so you will receive an email with a link to view the webinar on demand later this week. Attendance certifications are also available in that email. We really appreciate you completing a very brief survey that'll pop up when you exit the webinar. Special thanks again to Tek Cheng for sharing his expertise and to Catherine for her help in making these Hexagon webinars possible. Everyone have a great day and tell a friend about Hexagon and Directions Magazine.